All right, so we'll do a little tutorial on using the inverse normal distribution on the Texas Instrument 83 and 84. The easiest way to use the feature for inverse norm on the calculator is when you're calculating from negative infinity to a value. It's an inverse, so you're taking a percentage in decimal form and calculating the corresponding x value that is associated with it. So in this case, using the mean of 84 and the standard deviation of 6, we ask the question, what score corresponds to the 28th percentile, or above 28% of the data? So the way it works is you're calculating from the left, which is negative infinity to your value, which you don't know yet. So you put in your percent in decimal form, the mean and the standard deviation. So in our case, 28% corresponds to 0.28. The mean is 84 and the standard deviation is 6. So using our calculator, we have second distribution, arrow down, inverse norm, and so I put 0.28, comma, 84, comma, 6, my standard deviation, and that corresponds to a score of approximately 80.5. So what that tells me is this x value is approximately 80.5. However, what's often equally useful but not as direct is when I'm asked to go in the other direction. So we always want to calculate from the left, but sometimes that's not the case. For example, if you wish to find the score below 10% of the data, so I'm calculating from my x value all the way to positive infinity, and that's 10% of, or below that 10%, so it's the top 10% defining line. We can't do that. We need to calculate our percent from the left, so I simply subtract that from 100%. So we rewrite the percent as calculated from the left, which would be 100% minus 10%, which is 90%. So the same position, but now coming from the left from negative infinity to our value x, which gives us 90%. So again, I'd put that in the calculator as my percent in decimal form, the mean, the standard deviation. And I would go ahead and go to second distribution, or vars, and down to inverse norm, 0.9, comma, 84, comma, 6, and so my value would be approximately 91.7. So then x would be approximately 91.7. And that's all there is when we are calculating raw values x for inverse norm.